The endocrine system is a series of glands that produce and secrete hormones that the body uses for a wide range of functions. These control many different bodily functions. Some of those functions would include respiration, metabolism, reproduction, sensory perception, movement, sexual development, growth. Hormones are produced by glands and sent into the bloodstream to the various tissues in the body. They send signals to those tissues to tell them what they are supposed to do. When the glands do not produce the right amount of hormones, diseases develop that can affect many aspects of life. The endocrine system plays a large part in maintaining homeostasis. Homeostasis, of course, being the tendency to resist change in order to maintain a stable, relatively constant internal environment. Now, the endocrine system depends on key organs of the body. They would include the hypothalamus, pituitary gland, thyroid gland, parathyroids, adrenals, thymus, pancreas, pineal gland, and the reproductive organs, which would be the ovaries and testes. So, the main neural control center is the hypothalamus, also known as the master switchboard. Suspended from the hypothalamus by a thin stalk is the pituitary gland. The hypothalamus sends messages to the pituitary gland. The pituitary gland, in turn, releases hormones that regulate bodily functions. Hormones are essentially chemical messengers. Hormones alter the metabolism of target organs by either increasing or decreasing their activity. These changes in activity are strictly balanced to maintain homeostasis. Some examples of hormones would include insulin, which acts to lower blood glucose levels, which is in the pancreas. Parathyroid hormone, it increases blood calcium levels in the blood when they are low, which is in the parathyroid glands. Growth hormone, which acts to promote growth of bones and organs, in the anterior pituitary. Testosterone, which promotes the development of male sexual characteristics, including sperm development, which is in testicles. And glucagon, acts to raise blood glucose levels, which is in the pancreas. Positive or negative feedback systems. With negative feedback systems, they decrease the deviation from normal values. Most endocrine glands are under negative feedback control. An example of negative feedback would be the regulation of blood calcium levels. If calcium decreases, the parathyroid glands sense the decrease and secrete more parathyroid hormone. Positive feedback is when the original stimulus is promoted rather than negated, and it is rarely used to maintain homeostatic functions. An example of positive feedback can be found in child labor. The hormone oxytocin stimulates and enhances labor contractions. There are also a variety of diseases that can affect the endocrine system. Some would include diabetes, which impairs the ability of the pancreas to produce or respond to insulin and thereby maintain proper levels of sugar or glucose in the blood. Gigantism. If the pituitary gland produces too much growth hormone, bones and body parts may grow too quickly in children. Alternatively, if growth hormone levels are too low, growth might be stunted. Precocious puberty. Abnormally early puberty that occurs when glands incorrectly, so the body releases sex hormones too early. And now on to May with the immune system.
The function of an immune system is so that it can attack organisms and substances that invade the body systems and cause disease. An example is that in the presence of allergens, it can cause swelling, sneezing, and watery eyes. Tiny glands in the skin makes oils that improves the barrier function of the skin. Immune cells that live in the skin provide the first line of defense against infections. The skin helps your body regulate temperature.
Nonspecific immunity is the defense system in which you were born with. It protects you from antigens. Innate immunity involves barriers. These barriers form the first line of defense. The specific immunity is turned on when the innate system fails to clear the pathogen.
When the body is invaded by bacteria or parasites, an immune system alarm goes off, setting off a chain reaction of cellular activity in the immune system. Macrophages or other immune cells might be deployed and try to help attack the invading pathogen. For the most part, they do the job, but sometimes the pathogen gets through and the body turns to B and T cells. These cells are the special ops. They are a line of defense that uses past behaviors and interactions to learn to recognize specific foreign threats and attack them when they appear.
Nonspecific immunity is the defense system in which you were born with. It protects you from antigens. Innate immunity involves barriers. These barriers form the first line of defense. The specific immunity is turned on when the innate system fails to clear the pathogens.
The goal for vaccines is to stimulate the humoral response. The body remembers the antigens of specific organisms by inoculation. Infectious microbes can be killed by antibodies alone or without T cells. Some diseases in the immune system are type 1 diabetes and rheumatoid arthritis. Treatments for diabetes is insulin, hormones, or dietary supplement. Treatments for rheumatoid arthritis are immune suppressive drugs or steroids.
Wow!